Okay, so in this video, we're going to introduce modular arithmetic. We're going to start with an example called clock arithmetic. So that's mod 12. So what time is it? 6 hours after 5 o'clock. So if I start at 5 o'clock, then you could see if I go around 6 hours, I go 1, 2, 3, 4, 5, 6, and we're at 11 o'clock. So in clock arithmetic, I'm going to write this as 5, and then I'm going to write a plus with a circle around it, 6, and that gives me 11 o'clock. Now we ask, what time is it 10 hours after 5 o'clock? So again, I'm going to write this as 5 plus with a little circle for clock arithmetic, 5 plus 10. And the question is, what is that equal to? Is it equal to 15? The clock doesn't have a 15. So if I were to start at 5 o'clock and I were to go around and add 10 hours, I would get 1, 2, 3, 4, 5, 6, 7. But once I hit the 12, remember the clock's, that's the highest number, and then we go 8, 9, 10 hours. So that puts me at 3. So it would be 3 o'clock. Another way to think about this is if I did regular arithmetic and I did 5 plus 10, I get 15. And then if I divide 15 by 12, I would get a remainder of 3. And that actually ends up being my answer from clock arithmetic. It's the remainder. We can write this using the modular arithmetic notation. And the way we would write this for clock time or clock arithmetic is we would write that 15 mod 12 is equal to 3. So let's do another example of clock arithmetic. 7 o'clock plus 11 hours, what would that give me? Well, 7 plus 11, we know that that's 18. 18 divided by 12 gives me a remainder of 6. So this would just be 6. And we can also do that just looking at the clock. So if I start at 7 and I add 11 hours, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And as we calculated, we get 6 o'clock. So clock arithmetic is an example of modular arithmetic, and in this case, we use a modulus of 12. Another similar example is day of the week arithmetic, okay, and this is modulus 7. So here's an example. 3 days after Saturday is, so here's Saturday, and we would have 1, and then going all the way to Monday, 2, and then 3 leaves me Tuesday. So I can see that that is just Tuesday, which corresponds to 2. So using day of the week arithmetic to make this calculation, I would start at Saturday, which is 6, and I am going to write another special addition symbol with a square around it, and I'm going to add 3, and what does that equal to? So based on what we just showed, that's equal to 2 in day of the week arithmetic because it's Tuesday. But when we think about our normal arithmetic, we think, okay, 6 plus 3 is equal to 9. However, we divide 7 into 9, and the remainder is 2. Okay, and then that's really what the remainder is the answer that we get in in day of the week arithmetic. And we can write this as 9 mod 7 is equal to 2. So this just means that when we divide 9 by 7, the remainder is 2. And that's the answer that we get in our day of the week arithmetic. So let's do another example in day of the week arithmetic. What is 4 plus 11 in day of the week arithmetic? I'm going to do it with the remainders. So we know that 4 plus 11 in regular arithmetic is equal to 15. And if I divide 15 by 7, the remainder that I get is 1. So that would be my answer in day of the week arithmetic, 1. 4 plus 11 is 1. So let's take a look at if this measures up with our intuition if we actually look at the days. So the fourth day of the week is Thursday. Now if I add 11 days, if I go ahead 11 days into the future, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I'm back to Monday, so that is 11, and that is the first day of the week, that's Monday. So that measures up with our intuition. This can be written as 15 mod 7 is equal to 1. So if I divide 15 by 7, the remainder is 1, and that gives me the answer in my modular arithmetic. So let's do one more example. 39 days after Tuesday is, so let's say we start at Tuesday, and Tuesday is 2. So this is what we're actually looking for in days of the week arithmetic. And we pretty much have seen that this is, I just take the regular arithmetic, 2 plus 39, and then I'm going to calculate the remainder. And so what does this give me? So 41, if it is divided by 7, I get 7 times 5 is 35, so we get a remainder of 6. So this is 6. So that gives us the answer is the 6th day is Saturday. So the last thing I want to say about this example is that day of the week arithmetic is an example of modular arithmetic with a modulus of 7. So here are the general definitions. A mod n is equal to the remainder when a is divided by n. So for example, 11 mod 3 is equal to 2. Okay, and that's because if I divide 3 into 11, it goes 3 times, and the remainder is 2. So that's where we get this 2. Another example would be 14 mod 5. That is equal to 4. Because again, if I divide 4 into 14, if I divide 5 into 14, goes in twice, and the remainder is 4, so that's where we get this guy. We can also say the expression B is congruent to A mod n if they both if A and B have the same remainder when divided by n. So if B and A have the same remainder when I divide by n, then we would say they are congruent. So for example, in the above example, we found that 14 mod 5 is 4. That's also true of 19. If 19 is divided by 5, the remainder is 4. So I could say 19 is congruent to 14 mod 5. The last thing I want to show you in this video is how to perform modular arithmetic, or next to last thing. And basically all we do is we just perform the usual arithmetic, and then we take the remainder. So, example, if I had 27 plus 18 mod n, or mod 10, I would first calculate this arithmetic. So 27 plus 18 is 45. So this is 45 mod 10. And if I divide 45 by 10, the remainder is going to be 5. So this is just equal to 5. Here's another example of modular arithmetic. 37 times 3 mod 15. So first we're just going to do the usual arithmetic. 37 times 3 is 111 mod 15. So I'm going to divide 111 by 15, and it goes in, let's see, I believe 7 times. That would give me 105. If I subtract, I get 6. So this is equal to 6. So another example, 57 minus 13 mod 11. So I'm going to do the arithmetic first. We have 57 minus 13, and that's 44. And if I divide 44 by 11, I get a remainder of 0. So 44 mod 11 is equal to 0. 0 is the remainder here. Okay, part B, if it is 11 o'clock now, what time was it 43 hours ago? Again, I'm just going to look at the 43, and I want to know how many full rotations around the clock did we go backwards. So I'm going to look at 43 mod 12. So what is that equal to? I'm going to divide 43 by 12. So it looks like I have 36 and then I have 7. So the remainder is 7. So it looks like I go 3 rotations around the clock and then 7 additional hours backwards. So I would go around the clock 3 times, and then finally I would arrive back at 11, and then I'm going to go back another 7 hours. So 1, 2, 3, 4, 5, 6, 7, which brings me to 4 o'clock. So the answer in this case would be 4 o'clock.